this lesson, we're going to learn about the quotient rule, how you can divide things with exponents. Then we'll take a look at negative exponents and one specific application of those exponents, which is scientific notation. In a previous section, I gave you guys the product rule, which says when you multiply something with exponents, you add the exponents. In this section, I'm going to give you the quotient rule, which says if you want to divide with exponents, you subtract the exponents. For example, in 1a, the quotient rule says we would subtract the exponents. 6 minus 2 is 4. And so my answer would be y to the fourth. I can understand why this is true if I actually write out what's happening here. Y to the 6 means we have a product of 6 y's, and we're dividing by a y squared, a product of 2 y's. You have a common factor of y. You actually have two common factors of y. And you can see you're left with the product of 4 y's, or y to the fourth. So let's use the quotient rule on a few other examples. 10 minus 4 is 6, so I would get x to the 6. And 5 minus 1 is 4, y to the fourth. Now, if you're dividing something that has coefficients or numbers, the quotient rule works the same way, except you can divide those numbers like you normally would. So in example C, 10 divided by 5 is 2. And then a to the 5 divided by a squared, we would subtract the exponents to get a to the third. B to the fourth divided by b to the 1 becomes a b to the third. And finally, c to the 1 divided by c to the 1, the c is actually going to disappear here. It's technically a common factor. You could even think of it as you're canceling those c's out. Or if you want to use the quotient rule here, the c divided by c, you would subtract the exponents, you get c to the 0, but anything to the 0 power is 1, and multiplying by 1 doesn't actually change the value of the expression. So if you have the exact same factor in the numerator and the denominator, you can just cancel out that common factor. And so my final answer would be 2a to the third, b to the third. Now the quotient rule works regardless of what kinds of exponents you have. And with the quotient rule, we always take the exponent in the top and subtract the exponent on the bottom. So for example, in D, if I want to use the quotient rule, I would get x to the 2 minus 4, which is x to the negative 2. Notice that in this case, the quotient rule is giving me a negative exponent. To understand what that negative exponent actually means, I'm going to write out what's happening in this problem. We have an x squared divided by x to the fourth. That means we have two factors of x in the top and 4 in the bottom. We could treat this like a fraction and reduce our common factors of x. If we cancel everything out of the numerator of a fraction, we're actually left with a 1. When we're canceling, we're technically dividing things out. And in the denominator, I have x times x, or x squared, left over. So I did this problem using two different methods. Using the quotient rule, and also thinking about this problem as a fraction. The quotient rule always works, and so that tells me x to the negative 2 is the exact same thing as 1 over x squared. And so that brings me to the next definition I'm going to give. Negative exponents are defined to be reciprocals. We just saw this in the last example, but for example, if you have x to the negative 4, using this definition, that would be 1 over x to the fourth. Again, negative exponents mean reciprocals or fractions. They don't actually make the number negative. They just mean you have a fraction. So let's practice rewriting expressions with negative exponents using positive exponents. Using that definition I just gave you, y to the negative 2 is the same thing as 1 over y squared. And 3 to the negative 1 would become 1 over 3 to the 1, or you could just write that as 1/3. we can use the same property in example C, but notice we have a positive exponent with the x. We just have an x squared, so I'm not going to do anything with that term. And then the y to the negative 3 becomes a 1 over y to the third. Now, we can think of that x squared as an x squared over 1, and we can multiply straight across and write this as x squared over y to the third. And in fact, if we take a second look at this problem, rather than writing that intermediate step down, if I see something that has both a positive and a negative exponent in it, I only take the term with the negative exponent and I move that one to the bottom. So I would leave the x squared on the top, and I would move the y to the third to the bottom. We can use that idea in example D. The 2 doesn't have a negative exponent. Again, this is 2 times a to the negative 4. The negative 4 only applies to the a. So if I want to write this using positive exponents, only the a would move to the bottom. The 2 would stay on the top, and then I'd have an a to the positive fourth on the bottom. Now, if both pieces have negative exponents, we move both of them to the bottom. We'll have a 1 on the top. So example E would become 1 over p to the fifth, q to the third. Again, we move everything with a negative exponent to the bottom. So what if our negative exponent is already on the bottom of a fraction? Well, it turns out negative exponents mean reciprocals, which basically means you can flip it. And so I'm going to do example F a long way, and then I'll show you the fast or the short way of doing this problem. So in this problem, technically we have a 1 divided by x to the negative 1. We've learned that x to the negative 1 is the same thing as 1 over x. And if you want to divide fractions, you copy, change to multiplication, and flip. And 1 times x is just x. So that's the long way of understanding what this expression simplifies to. But the faster way is to recognize if you have something with a negative exponent, you can always move it to the other side of the fraction bar and make that exponent positive. And so you would just get an x to the 1 in the numerator. So let's apply this shortcut. Let's see if we can apply this shortcut to example G. Anything with a negative exponent, I am going to move to the other side of the fraction bar. So that means the x to the negative 3 moves to the bottom and becomes an x to the positive 3. And the y to the negative 5 moves to the top and becomes a y to the positive 5. Again, only the things with negative exponents move. Anything with a positive exponent stays where it is. So in example H, the only negative exponent is in the bottom. That moves to the top. And the a to the fourth will stay on the top. It'll stay where it is. And so this becomes a to the fourth, b to the third. Now, if you don't like this shortcut I've shown you, you can always write these problems out and actually do the division. In example H, you have an a to the fourth, and you're dividing it by b to the negative 3. So that is a to the fourth divided by 1 over b to the third. Copy, dot, flip, and then you can see if you multiply straight across, you get the exact same answer. Now, if I want to evaluate expressions with negative exponents, if I actually want to do the computation, I'm going to have to rewrite the problem using positive exponents first. So 5 to the negative 2, the very first thing I do is I write that as 1 over 5 squared. Once I have a positive exponent, I can do the math. 5 squared is 25, so this becomes 1/25. Now in part B, we have a negative. And remember, if you don't have parentheses, the exponent only applies to the 5. It doesn't actually apply to the negative. This is the same as a negative 5 to the negative 2, or negative 1 over 5 squared, or negative 1 over 25. The exponent only applied to the 5, not to the negative. But if you have parentheses like in example C, the exponent does apply to the negative. And so to rewrite this one with positive exponents, I would actually bring that negative 5 to the bottom in order to make that exponent positive. Now negative 5 times negative 5 is positive 25, and so those parentheses actually change my answer a little bit. All right, let's do a couple more like this. Again, the key to each of these problems is rewrite with positive exponents and then evaluate. Don't try to do the work in your head. It's really easy to make mistakes here. Negative exponents don't give you negative answers. They mean fractions. Now, we just learned if the negative exponent is on the bottom, we can actually move it to the top, and this is going to become a 5 squared, or 25. We also learned in the previous example, we only move the things with negative exponents. So in part E, the 2 is going to stay on the top, and the 3 to the negative 3 moves to the bottom and becomes a 3 cubed. 3 cubed is 27, and so my final answer is 2 over 27. Once again, we only move the things with negative exponents, so the 6 will move to the top, the 4 will stay on the bottom. This is going to become 4 times 6 to the 1, or 4 times 6, which is 24. Now we're going to come back to negative exponents in our next section and use all of our laws of exponents with these negative exponents. But for now, I really want you to focus on being able to rewrite things with negative exponents using positive exponents.